Hello students, welcome to the interesting chemistry where you will find an atmosphere of classroom teaching. If you want to enjoy a classroom teaching from your study room, then please watch my video of interesting chemistry. Today I am going to explain you the applications of mole concept. In continuation of the mole concept, it's my third video. In my first video, I explained about the mole concept. In second video, I have explained about some applications of the mole concept. The applications were the first, how will you get the mass of one atom, one ion, or a one molecule? First one. Second one, the interconversion of gram into mole, mole into gram, mole into number of ions, molecules and atoms and so on. And the third one, the relation between mole and the volume of gases. Today I am going to explain you the most important application of the stoichiometry, that is stoichiometry. That is stoichiometry. It's the most important application of the mole concept. This stoichiometry word is made up, it's a Greek word. It is made up of two words, that is stoichion. Stoichion means element, and the metrion means measurement. The measurement of elements in a chemical reaction is called as stoichiometry. But for the journal, the measurement of the amount of compounds which are taking part in a chemical reaction is called the stoichiometry. Finally, stoichiometry deals with the calculation of required amount of reactants. Calculation of required amount of reactants to get the desired amount of products. To get the desired. So it is. So again I am telling you, what is stoichiometry? Stoichiometry deals with the calculation of the required amount of the reactants to get the desired amount of products. That is stoichiometry. So now, as I told you, that is a way of calculation. But to calculate about the reactants and the products, we should have some information. So from where will you get the information about the reactants and the products? So you know the best source of information of a chemical reaction is chemical equation. So first of all, to calculate the amount of reactants and products, first of all we write the balanced equation that I have taken the example here. Calcium, when calcium carbonate or the limestone is heated, it decomposed into lime, calcium oxide and carbon dioxide. It's a balanced equation. Here this S tells us about that this calcium carbonate is solid, it is also solid, and CO2 is one gas. Again, this calcium carbonate is a 1 mole and 1 mole. So this a chemical equation, balanced chemical equation, tells us when 1 mole of calcium carbonate is heated, it gives the 1 mole of carbon dioxide, that is equal to the 22.7 liter at STP, standard temperature pressure. So again you can say the 100 gram of calcium carbonate, when heated, it gives us 56 gram of calcium oxide and 44 gram of carbon dioxide. These are the information about this reaction that we can find from the chemical reaction, the chemical equation. So this one. Now, if you require 80 kilogram of 80 kg of CaO, what will be the amount of limestone to heat to get the 80 kg of calcium oxide? So this equation tells us, take it in kilogram. Now here 56 kilogram, you can obtain 56 kg from 100. 56 kg from 100, so 1 kg to 100 upon 56 kg, and you require 80 kg. So you can calculate the amount of required calcium carbonate from this equation. Now I am taking the example of second equation, that is the combustion. That is the combustion of methane. This is the second equation, methane. This CH4 plus 2H2O is equal to CO2 plus 2H2O. 2O2, please, sorry. So here all the two reactants and the two products, all the four compounds are in a gaseous form. As I written, this is about the gaseous form. And this also tells one mole of methane is heated with 2 mole of oxygen, we will get the 1 mole of carbon dioxide or 2 mole of H2O. This is very simple. Here one thing I want to tell you, this special that I didn't tell you here, but here I want to. What is this 2 and this 2? These number we add, we multiply this oxygen by 2, we multiply this water molecule by 2. These, the number that is multiplied for the balancing of the equation, these numbers are called stoichiometric coefficient. Stoichiometric coefficient, coefficient, coefficient. Please always remember the stoichiometric coefficient, these numbers. So, if you are asked in your examination, what do you mean by stoichiometric coefficient? Then you can say the number we use to multiply the reactants or the products to balance the equation are called the stoichiometric coefficient. Now here, what is the stoichiometric coefficient for calcium carbonate? Never say nil, because you hear only one molecule, it is one molecule, so the stoichiometric coefficient for CH3 is 1 mole. So here CH4, if anybody asks you what is the stoichiometric coefficient of methane, you will say here we multiplied by nothing, then you can say nil. No, that you will wrong. It is multiplied by the 1. So the stoichiometric coefficient of CH4 is 1. The stoichiometric configuration is 2. So I think that you have understood about the stoichiometric coefficient. And now this is so many information, you can get so many information from, you can the information in 1 mole to mole, but again and when 1 mole of methane is heated with 64 gram of oxygen, then we will get 22.4 liter of carbon dioxide and 36 gram of water. The statement, you can write so many statements, as you can write in this way: 1 molecule of CH4 when plus 2 molecule, when heated with together, they will produce 1 molecule of CO2 and 2 molecule of H2O. But I am saying when 1 mole is 64 gram of oxygen, it will produce 22 point. So in this way, you can write so many statements. I think that now if I say to you that what amount of methane is required to get the 5 mole of CO2. So here 1 mole, you require here 5 mole. So here 5 mole of methane will be required to get the 5 mole of CO2. So in this way, from these equations, chemical equations, you can calculate the required amount or the desired amount of the reactants and products respectively. So for this, to make your understanding more clear about this, about the calculation, I have a list of questions. So I will solve this question with you. These are the questions for your practice. These questions are known as the numericals based on chemical equation. So for the first question, calculate the amount of calcium carbonate in gram to get 0.2 mole of CO2 on heating. It's about the chemical reaction of the decomposing of the calcium carbonate. When the calcium carbonate is heated, CaCO3, it decomposes into CaO and CO2. It's a very popular equation. When limestone is heated, it gives the lime and the carbon dioxide. It decomposes into calcium oxide and carbon dioxide. So here from this equation, 1 mole of calcium carbonate on decomposition gives us 1 mole of CO2. So here you want only 0.2 mole required. You want to get only here 1 mole is produced and here you want to 0.2 mole. So this equation tells us that 1 mole CO2 is produced by 1 mole CaCO3. I think do you understand what I am saying? From this equation, 1 mole of CO2 is produced by 1 mole of CaCO3, and so you will require here 0.2 mole. So the 0.2 mole CO2 will be produced by 0.2 mole CaCO3 on very simple cases. 0.2 mole. So the answer of this question must be 0.2 mole if you have to answer in the unit of mole. But you have to answer in the mole, calcium in the gram. So now you have to convert this mole into gram. So convert. So how will you convert? The 1 mole of calcium carbonate is equal to 100 gram. The molar mass of the calcium carbonate 40 plus 12 plus 48. This is equal to the 100. So the molar mass of this calcium carbonate is 100. So 1 mole is equal to 100. 0.2 mole is equal to 0.2 into 100. It will be 20 gram. So it will be the answer of the first question. It's very easy question, but something you have to understand about these questions. So again, I am coming for the second question, that is what amount of O2? That is what amount of O2 in gram is required for the combustion of 45.4 liter of CH4 at STP. So this question is about the combustion of methane. So first of all, you will write the equation of the combustion of methane. The combustion of methane, CH4 plus O2, then CO2 plus 4H2H2O. Then you require here 2O2 is this. This is the balanced equation of your this reaction. So the combustion of methane. Now, here, calculate the amount of oxygen. This will be, you have to calculate the amount of oxygen. And for the combustion of 45%, so here only these two. So the 1 mole of CH4 requires for the combustion 2 mole of oxygen. So again here, on combustion, 1 mole of CH4 on combustion requires 2 mole of oxygen. For the combustion of 1 mole of CH4 requires 2 mole of oxygen. This equation tells us about. So we have to calculate the amount of O2. So O2 is here. So again, you have 45 liter of CH4. This question can be solved in two ways, in two methods. First of all, here this is the mole, this is the 1 mole, and this is the liter. What is the volume of 1 mole of CH4? The volume of 1 mole of CH4 is equal to the 22.7 liter at STP. I have explained you in my previous video. So always the 22.7 liter at STP of any gas will be equal to the molar mass of that gas. So the 1 mole is equal to the volume of 1 mole of the CH4 is equal to 22.7 liter STP. So here, and that's and for the 1 mole you require 2 mole of O2, and convert this mole into gram. So 1 mole of O2 is equal to 32. So the 2 into 32, 2 into 32, that is 64. So from this equation tells us 22.7 liter of CH4 at STP requires for the combustion 64 gram of oxygen, gram of O2. This is O2. And what is the volume do you have? 45. So the for 1 you write here 64 upon 22.7 and then 45.2 into 45.2 here. So I think this is just double. So you write here 128 gram will be the answer of this question. Don't go to my handwriting, don't go to my, I am scribbling, my aim is to make you understand. I think that you understand from this equation. For the combustion of 45.4 liter of methane, you will require 128 gram of oxygen. Now I will tell you the second method. How will you get the second method? Suppose it is from this equation, for 1 mole of CH4 requires for the combustion 2 mole O2. Now first change this volume into mole. What will be? How will you change? Mole is equal to the volume of the substance, volume of the gas in STP, that is 45.4 upon divided by 22.7. So it is equal to 2 mole. So the here mole. Now here 1 mole CH requires 2 mole of O2. Now here 2 mole. So the 2 mole of CH4 will require is equal to 2 into 2 is equal to 4 mole of O2. 4 mole of O2. So now you have to answer in gram. You have to answer in gram. So 1 mole of O2 is equal to 32 and 4 mole will be equal to 128. That will be the answer of the, again the answer is 122. By either method you can solve this question. So I think that you have understood. Now I am coming to the third question. What amount of C2H6 is in gram required to produce 68.1 liter of CO2 at STP? So CO2 STP, ethane. This is about. So this is the question of the combustion of ethane. Now you have identified that this question is based on the combustion of ethane. So first write the balanced equation of the combustion of ethane. So how will you write? C2H6 plus O2. It is 2 carbon 2, then you can write here 2 CO2, 6 oxygen hydrogen, you will write here 3 H2O, 3 H2O, C2H6. So 2 into 2 plus 3, 7 oxygen, you required here 7 oxygen. So this you will multiply this O2 with 7 and this is your balanced equation. I am telling you the way how will you balance the equation. This is your balanced equation. Now this 7O in a chemical equation you can't write any gas in a atomic form. Always the gas is written in the molecular form. So you have to multiply this by 2. So to multiply this whole equation by 2 and this will be the 4 and this will be the 6. It is your balanced equation. So come to the equation. What amount of CO2 is required for 61 CO2? 61. This 4th mole. 4 mole of CO2 is formed and to form 2 mole of C2H6. So this balanced equation tells you that the 4 mole of CO2 are formed from 2 mole of C2H6. This equation tells us the 4 mole of CO2 is formed from 2 mole of C2H6. It is again. Now, how many moles do you have to find? 6.26. This is again change into this volume should be changed into mole because here is mole. So here volume will be 68.1 and you will divide it by 22.7. So it's I think the 2266 3 moles. It is equal to 3 moles. So 4 multiplied 2, then 1 mole upon 2 by 4, and for 3 moles you will write here 3, 2 and 1.5 mole will be the answer. 1.5 mole of C2H6 will be required to produce 68.1 liter of CO2. From this equation you have solved. Again I am telling you, please don't go to my writing. It is my main aim is to make you understand about the program. So 1.5, but you have to give the answer in gram. Again C2H6, the molar mass of C2H6 here is 30, 24 plus 6. So here 1.5 into 30 is equal to 45 gram will be the answer of this question. So please here the main thing is that you should know about the conversion of the unit, mole into gram, gram into mole, and mole into volume and volume. This all I have explained in my previous video. I have given all the formulas for the conversion of these units. So please first understand how will you convert these units into each other, 1 to gram to mole to gram, etc., then you can solve these questions very comfortably. So that's all for today. One thing, please like it and share my video, and also share it with your friends who are preparing from their home. So that's all for today. Thank you very much.